Alright, in this problem, we're given that a city started with a population of 16,000 and it grew at the rate of 7% per year. The current population is 27,490. How many years did it take to reach this size? So I started off by writing the formula for exponential growth. It's y equals a times 1 plus r to the t power, where a is going to be your resulting amount, and I'll actually just write this down in case you need a quick review. A is going to be the resulting amount. Actually, I'll do that one last. A is going to be your initial amount. So I'm just going to write IA for initial amount. 1 plus R is going to be the rate. T is going to be the time. And then Y is going to be the resulting amount. I'm just going to put RA after the given period of time T has passed. So now that we know our exponential growth formula, we're going to be taking a look at the problem. So we know that, I'm just going to go back here. We know that a city started with a population of 16,000. So if it starts with a population of 16,000, we know that our A is going to be 16,000. So we can just fill in this first as 16,000 times 1 plus r. The rate is 7%, which we need to write as a decimal, and we can write that as 0.07. We don't know the time, that's what the problem is asking, but we do know that the resulting amount after the time has passed is 27,490. That's the current population. So we're going to write 27,490. So we have 27,490 equals 16,000 times 1 plus 0.07 to the t. Now, to solve for t, we're going to obviously have to be using logarithms, but before we do that, we're going to divide both sides by 16,000. We want to get this term by itself, so we're going to just divide both sides by 16,000. Here's where you want to use your calculator. So I have 27,490 divided by 16,000, which gives me 1.718. 1.718. 125. Let's just write 125. Okay. And then we have the 16,000s here cancel out, equals 1 plus 0.07 to the t. 1 plus 0.07 to the t. Now, we cannot, we actually should simplify this one step further. I forgot to do this part. You want to write this as 1.07 to the t, so we can simplify that fully. 1.07 to the t. Now, since we can't get like bases, we're going to take the log of each side of the equation. So we're going to get log 1.718,125 equals log 1.07 to the t. Now, based on your third law of logarithms, we can move the t out in front. So we're going to get log 1.718,125 equals t log 1.07. Now to solve for t, we just divide both sides by log 1.07. And you're going to use your calculator. Remember to divide, so we're going to get log, and then we're going to divide 1.71, 8125 divided by log 1.07. And when we divide, we're going to get 7.999473713. So we're going to get, so I'm just going to write this down, 7.9994, and that should be fine, equals t. So I'm not sure. Let me just check again what the problem's asking. How many years it takes to reach this size? So I'm going to assume, I'm not quite sure if you want to round to the nearest year, to the nearest hundredth, whatever. We're going to say 8 years because it's right around 8 years. So we're going to say 8 years for the population to reach this size. Like I said, if the question asks you to round differently, make sure to round to that. But 7.994, 73713, it is very close to 8 years. So if 8 years should be an acceptable answer, but do what your assignment says. So it takes 8 years for the population to become this large.